And we should be live. Hi everyone. Let me stop here. Sound check. Let's go. We put this here. Okay. Nice, nice. Okay. Let's see if we are live or not. Yes, we are live. Okay, so we can start. Let me move a bit here. Okay, one moment. So this. Yes, okay. Let's see if the sound is okay. Hi everyone. Hey, hey, there. Sound check. How is the audio? Today will be a very interesting episode because and lesson because we go through the common programming concepts of Rust. Audio good. Nice, nice, nice. Let's try to. Okay. Amazing. Perfect. Okay, nice, nice, nice. So this is the first Rust live stream of 2023 and I'm super excited. Let's go. I forgot the water. Okay, nice. Let's go to the common programming language concepts. Give me 10 seconds to get the water. We'll be back. Okay, let's go. So okay, so today we are at chapter 3. I don't know if I write code today, but I think I can write some easy code. And let's go to with the common programming concepts. So this chapter covers concepts that appear in almost every programming language and how they work in Rust. So it's a Rust-specific common programming concepts chapter. Very, very important. Many programming languages have much in common and at their core. So if you already know a programming language, it will be easier for you to learn Rust. Especially it fits JavaScript because it might be hard to master it. But we'll discuss them in the context of Rust. Specifically, you learn about variables, basic types, functions, comments, and control flow. You're all here. Nice. Rust has a set of keywords. Keywords are reserved words that you use for the program itself. Like I think you can't name a variable if or for because they are reserved keywords. Okay, let's go with this one. Hi everyone. Let's go. So variables and mutability. As mentioned in the storing values with variables section, by default, variables are immutable. This is very important because it's not like that in all the programming languages. This is one of many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. However, you still have the option to make your variables immutable, otherwise it becomes a problem. Hey Krupali, how's it going? Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out of the immutability because you want a variable that changes the values probably. When a variable is immutable, once a value is bound to a name, you can't change that value. Just got my lens handled. There we go, Krupali. Let's go rush on lens. To illustrate this, generate a new project called variables in your projects directory by using cargo new variables. So I'll do it now. So we have this one. I am already in the projects folder By the way, this is also a GitHub repo on this, so I can do cargo new variables. So I'm generating, you can read, you can generate a new project called variables. Let's see. It's done. Okay. Done. And now, okay. Then your new variables directory open src main.rs. I'm going faster here because we've already been doing this for a while. Cd variables, and we open this with our favorite IDE, for example VS Code in my case. There we go. I think there is a tool for putting these windows in a default way. By the way, we have this new Rust project called variables. Let's go here. We should type let x print ln x equals 6 print ln. Okay, so let's take this part and then let's copy paste this into main. Going well, Arya? Okay. And I really see the error here. So, but let's see, let's try to run this. And we have the error, right? Could not compile variables with the previous error because this is an immutable variable and I try to assign this to a different value. Let's go back here and we have the error. Okay, this example shows how the compiler helps you find error in your programs. Compiler errors can be frustrating, but really they only mean your program isn't safely doing what you want it to do yet. They do not mean they are not that you are not a good programmer. Experienced Rusticians, that are programmers to write Rust, I don't like this name, still get compiler errors. Of course, you receive the error message cannot assign twice to immutable variable x, because you try to assign a second value to the immutable x variable. So this is exactly like when we type const in JavaScript. The only thing that I don't like is that there is the same keyword let, but in Rust let means constant variable. So in JavaScript let is the same as putting let mux. Okay. It's important that we get compiler time errors when we attempt to change a value that's designed as immutable, because this very situation can lead to bugs. If one part of our code operates on the assumption that a value will never change and another part of our code changes that value, it's possible that the first part of the code won't do what it was designed to do. The cause of this kind of bug can be difficult to track down after the fact, especially when the second piece of code changes the value only sometimes. The Rust compiler guarantees that when you state that a value won't change, it really won't change, so you don't have to keep track of it yourself. Your code is thus easier to reason to. Okay. I like that we are doing this after doing an example, but mutability can be very useful and can make code more convenient to write. Although variables are immutable by default, you can make them mutability by adding mut or mute. Still don't know how to pronounce this. Okay, so you can say let mutable, so mute equal to 5, then assign to 6, and then it's okay. I think so. If we go back here, and we add the mute, I think it's spelled mute. I think it should be happy now. And the value is x, the value is 6. Okay? Makes sense. So let mux is equal to let. And let is equal to const, or the opposite, if you are a JavaScript developer. Like immutable variables, constants are variables that are bound to a name and are not allowed to change, but there are a few differences between constants and variables. Let's read this part. This part is very, very important. Like immutable variables, constants are values that are bound to a name and are not allowed to change, but there are a few differences between... Okay, I already read this one. First, you aren't allowed to use mute with constants. Okay, constants aren't just immutable by default, they're always immutable. You declare constants using... so there is also the constant... I think I blocked the Nightbot. No, I think the Nightbot has some issues redirecting on the channel, but it's okay. So there is the const keyword in Rust, so I can just use const and then let mute. Okay. And this type. Okay, type annotation. Okay, constants can be declared in any scope, including a global scope. Okay, so this is an example, and so when you use a const, you also use the uppercase method. Okay, interesting. Okay. Constants are valid for the entire time a program runs within the scope in which they were declared. This property makes constants useful for values in your application domain that multiple parts of the program might need to know about, such as the maximum number and so on. Okay, shadowing. Okay, let's see also this part. So, as you saw in the guessing game tutorial, you can declare a new variable within the same name as a previous variable. I remember this, you should check the old video. But basically you can decide, you can shadow an existing variable by declaring another variable with the same name. Interesting. For example, here we do let x equal to 5, let x equal to x plus 1, and inside this code block I say let x equal to x multiplied 2. Then we have this value and then this one. We can try to type this one and see what happens. Let's go here. Let's try to run. A bit smaller. Okay, let's go. Let's run. So here it says 12 and then 6. Does it make sense to you? For me it makes sense, because here we have this value called x, then we declare another variable called x, which is x plus 1, so its value is 6. Then inside this code block we declare another variable called x, which is x multiplied 2, and the value of the inner scope, this is the inner scope, this is the outer scope. So inside this inner scope the value of the variable is 12, and so we see this one. But outside this scope, so in the outer scope, the value is still 6. For me, this makes totally sense. Does it make sense to you? Hope so. Shadowing is different from making a variable as a mute, because we will get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on a value, but have the variable be immutable after those transformations have been completed. I'm reading here. The other difference between mute and shadowing is that because we are effectively creating a new variable, then we use the let keyword again. We can change the type of the value but reuse the same name. For example, say our program asks a user to show how many spaces they want between some text. Here, spaces.len. Okay. The first spaces variable is a string type, and the second space variable is a number type. So this is a number, this is a string. Okay. Shadowing those spaces us from having to come with different names, such as spaces str, that's for string, and spaces num. Instead, we can reuse the simple spaces name. However, if we try to use mute for this as shown, we will get a compile time error. Why? Because we can't have this mutable variable defined as a string, but then assign this to a number. We can't mutate the variable's type. Interesting. Let's go. Okay, so I think this is one of the most important parts to understand. Data types. So, every value in Rust is of a certain data type, which tells Rust what kind of data is being specified so it knows how to work with that data. We look at the two data type subsets, scalar and compound. Interesting. Let's see. Okay, Rust is a statically typed language. It must know the types of all the variables at compile time, and I like this, to be honest. The compiler can usually infer what type we want to use in case when many types are possible, such as when we convert it to a string, to a number section, we must add a type annotation like this one. This is the type annotation. Parse expect. This is super powerful of Rust, this .expect. Wow. If you don't add the U32 type annotation, Rust will display the following error, which means the compiler needs more information from us to know which type we want to use. Nice. Scalar types. A scalar type represents a single value. Scalar, it's like in physics. Rust has 4 primary scalar types: integers, floating point, numbers, booleans, and characters. Floating point numbers, okay. Integers, floating point numbers, booleans, and characters. You may recognize this from other programming languages. Let's jump into how they work in Rust. So we have 4 scalar types in Rust, which represents a single value. Integer types. Let's go. I think maybe we can skip. This is the size. Okay, but this is the integer. The floating point number is basically a float. Okay. Nice. Floating point F32, F64. Okay. Numeric operation. Numeric operations are this scalar value. Okay. Support the basic mathematical operation. Dev, we achieved the 12k on YouTube. Amazing. We need to double it. We need at least a 25k in 2023, maybe more. Let's see. Okay, so it can be an operation, and the Boolean type. It can be true or false, not capital. Okay. And then the character type. But one moment. It says 4, and here there are 5. 1 second. Integer, floating point numbers, booleans, and characters. And so why do we have numeric operations here? Okay, it's just explaining. So Boolean type and character type. So the Rust char type is the language's most primitive alphabetic type. Here are some examples of declaring char values. Okay. Nice. Note that we specify char literals with single quotes as opposed to string literals, which use double quotes. Rust char type is a 4 bytes in size and represents a Unicode scalar value. Okay, which means it can represent a lot more than just ASCII or ASCII, accented letter, Japanese, and so more. Okay, and now, so these were the 4 scalar types. Now, about the compound types, can grow multiple values into one type. Rust has 2 primitive compound types, tuples and arrays. So we have the tuple type, okay, is a general way of grouping together a number of values with a variety of types into one compound type. Tuples have a fixed length, okay. So this is the association between a type and another one, and the value. And tuples are usually very powerful. They're also available in Python and other languages. Tup. So we can define this type, the type of this tuple. Okay, amazing. Okay, x and z equals to. Okay, so we can define this type. Is very powerful. Okay. 0, 1, or 2. Okay. And now the array type. Another way to have a collection of multiple values is with an array. Like a tuple, every element of an array must have the same type. Unlike arrays in some other languages, arrays in Rust have a fixed length. So, okay, so we don't have dynamic length arrays. The arrays have a fixed length. Interesting. Arrays are useful when you want your data allocated on the stack rather than the heap. Okay, stack and heap. Or when you want to ensure you always have a fixed number of elements. An array isn't as flexible as the vector type. A vector is a similar collection, and okay. However, arrays are useful when you know the number of elements will not need to change. In this case, probably arrays are the best data type that you can use. Data structure, sorry. For example, if you were using the names of a month, we have the 12 elements as strings. You write an arrays type using square brackets with the type of each element. And I remember that in Rust, I think you can't have all the arrays must have the same type. So you can't have an array which has strings and numbers in it, which might be very confusing, to be honest. Okay, and okay, and now, okay, accessing array element. You can access to an array element with the index. Index, they start from 0. The first one is A0, A1, and so on. Let's see what happens if we try to access to a non-existing array element. We already had some of these. So expect. Okay. Thread main panicked. Okay. The len is 5, but the index is 10. Okay. Very clear. The program resulted in a runtime error at the point because you were accessing the index of that array at runtime. Okay, when you attempt to access an element using indexing, Rust will check that the index you specified is less than the array length. If the index is greater than or equal to the length, Rust will panic. Okay, interesting, this approach, panic. This is an example of Rust's memory safety principle in action. In many low-level languages, this kind of check is not done, and then when you provide an incorrect index, invalid memory can be accessed. Rust protects you against this kind of error by immediately exiting instead of allowing the memory access and continuing. Okay, this is very powerful. This is a very important part of Rust, because in Rust, if you try to access an invalid memory, the program exits. Instead, in many programs, it tries to access that invalid memory access. This is This is game changing. This is very powerful for a programming language. Amazing. The more I know more about Rust, and the more I like it. So functions, comments, and control flow. Let's see how much we can do today. Okay, I hope. I'm sorry if this might be not super interesting, but this is very important. This episode is very important. Yeah. By the way, we have a live stream tomorrow. Okay. Functions. Functions are prevalent in Rust code. You have already seen one of the most important functions in the language, the main function, which is the entry point of many programs. You've also seen the fn keyword, which allows you to declare new functions. Rust code uses snake case as the conventional style for function and variable names. Okay. In which all letters are lowercase and underscores separates words. Okay. Main, another function. Okay. Nice to know. We define a function in Rust by entering fn followed by a function name and a set of parentheses. The curly brackets tells the compiler where the function body begins and ends. We can call any function we have defined entering its name, so we're calling the function by a set of parentheses. Because another function is defined in the program, it can be called from inside the main function. Yes, right, Dev. We have 15 hours left for a kinda longer live stream. Tomorrow we have a 12-hour live stream. Yes. Parameters. We can define functions to have parameters, which are special variables that are part of a function's signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in a casual conversation, people tend to use the word parameters and arguments interchangeably for either the variables in a function definition or the concrete values passed in when you call a function. So technically the function has parameters, okay, in the declaration, but it's okay. Okay, so the declaration of another function has one parameter named x, this one. The type of x is specified as i32, so integer 32. When we pass 5, macro puts 5 where the pair of curly brackets containing x was in the formal string. Okay, in function signatures you must declare the type of each parameter. This is the deliberate decision in Rust design. Requiring type annotations in functions definitions means that the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. The compiler is also able to give more helpful error messages if it knows what types the function expects. When finding multiple parameters, separate the parameter declaration with commas, like this. Okay, makes sense. How much do we still need? Let's do it. Okay. Where were we? Okay, this here, statement and expressions. Function bodies are made up of a series of statements optionally ending in an expression. So far, the functions we've covered haven't included an ending expression. But you have seen an expression as part of the statement. Because Rust is an expression-based language, this is an important distinction to understand. Other languages don't have the same distinctions, so let's look at what statements and expressions are and how their differences affect their bodies of functions. Statements are instructions that perform some action, and expressions evaluate to a resultant value. For example, if you have a if, let's see. This is just definition. Okay, so, but let's read this part. Okay. We actually already used statements and expressions. Creating a variable and assigning a value to it with the let keyword is a statement. In listing tree 1, let y equal 6 is a statement. File name src main.rs. fn main let y equal 6. Okay. Among a main function declaration containing one statement. Function definitions are also statements. The entire preceding example is a statement in itself. Statements do not return values, therefore you can't assign a let statement to another variable, as the following code tries to do. You will get an error. Okay, file name. Okay. No, you can't. You can't do this as an assignment, of course. But here the errors are kinda good, so we understand what's going on here using the compiler. Cool. Okay, the let y equal to 6 statement does not return a value, so there isn't anything to do for x to bind it, etc. Okay. Expressions evaluate to a value and make up most of the rest of the code that you will write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be part of the statements. In listing 3.1, the 6 in the statement let y equal 6. Okay, nice. File name, so we have this part, and this is the expression. Okay. Function with return values. Function can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow. Oh. Ah, okay, so we have the arrow function, but is it the same as in JavaScript? Ah, 5 returns. So it seems similar to JavaScript. I don't understand if it's exactly the same. Okay. There are no function calls, macros, or even let statement in the 5 function, just the number 5 by itself. That's a perfectly valid function in Rust. Note that the function's return type is specified too. We define the type of the type we return. Cool. Very cool. Okay. I want to use this more in action with some program, but this looks very cool. Okay. So, for example, we have a function +1, which takes an argument and it. The song is very low on my end. Is the audio too high? Shubham Yadav. Ashketchum. No, the volume for me is very low. If it's too loud to you, compiling. Amazing. Comments. We're almost done. Comments. Let's see the comments and probably control flow. Let's see. Comments. Okay. Double slash. Let's see. Only this one. But I think that this is doable. But this works. This does work. Okay, so this works, but in the documentation they don't say this. documentation comments. Okay, let's go. And now the control flow. Maybe we can do the control flow, or we can do this next time. Next time we will do the control flow. So I think that we'll... Ah, okay. No, it's for me it's... the volume is good. I don't know, because I would like to make this understanding ownership as the next part. So now, I don't know. Maybe we can do it. 37 minutes, but I don't want them to be very long. No, I think that we are done for today. So I want to stop here, and then we'll start with the control flow next week. I don't want, because I've also a live stream tomorrow, 12 hours. So let's wrap up this live stream, and so a recap. I can try to give a recap here. Why is not working? Let's go with the small one. So the recap. We talked about some basic programming concepts applied to the Rust programming language. We started talking about variables and what is the mutability. We've also learned that there is a const keyword in Rust. I was not sure about this, which are used, of course, for the variables that they are meant to be constant forever. So in case you put const, you can't make mute a const variable, but you can do this with a let const. If we don't specify a mut, that it will be immutable too, but not a constant, which is a kind of different concept. And then we had another section where we talked about data types. We talked about scalar types and compound types. So scalar types, they are 4, and they should be integers, floating point numbers, booleans, and chars. Yes. And the compound types, they are tuples and arrays. Okay, this is a long story short. Amazing. Cool. And now another chapters on the functions in Rust. We've also discovered that there is an array function in JavaScript. It's not super clear if it's really the same as in JavaScript or it's a bit different. Can you see here this function with this arrow? And then a very small part for the comments. I don't understand why here it says that it's only with 2 slashes, but the slash star still works. So I don't know. Maybe this is intended to be. Maybe this is intended to be to write documentation. I don't know. I still don't know. It has the triple. No, it's something different. Okay, so let's go in full mode. So my impression, of course, this has been a necessary part to understand the core common programming concepts in Rust. Maybe it has not been the most funny one, because we had to go through some basics, but this is very important. It's very important to understand the core common programming concepts applied to Rust, because this will make us learning Rust way easier. So I'm happy of been doing this part, and yes, so that's it. I think that the next Saturday I'll move the Rust live stream just a bit later, so just we start 30 minutes later, because otherwise it clashes a bit with the 4 call, but we will have more or less the same time. Feel free to, we are about to close. Tomorrow we have the live stream for 12 hours for the Alchemy University Bootcamp. And that's it. I'm really enjoying Rust. The more I learn about Rust, and the more I enjoy writing code in Rust. That's amazing. Perfect. We're about to close, so if you want to say bye, you can now. And see you tomorrow on the 14th of January, 3:30 p.m. CT. Let's see. Thank you so much, Dev, for being here today. Amazing. Perfect. Nice. I'll add, as usual, all the chapters to this lesson, so you can also watch it after. And that's it. Perfect. We are done. Bye bye. Bye bye. But are you on Twitch? Bye bye. It says 0. Just want to check something because it says 0 on YouTube, but I see people, so I don't understand. Amazing. Perfect. I'm editing some videos, so let's see how it goes. Probably should put the I'm here, so I don't know. Okay, nice. Okay, so it's just broken. The counter is broken. Perfect. Bye bye.